All right, recording is rolling. So it's Tuesday, April 11. I have something a bit different right up for you guys today. I have a fun lab activity. And this is going to be more open-ended than our usual type labs. Before I explain that, I know a couple of guys were absent yesterday. There was this page that was sent out from administration yesterday. So I know we read this to you guys yesterday, but let's look at it real fast again, just in case you missed this. Re-enrollment is recurring for Brevard County students for 2023-24 is is currently available on the Parent Focus portal. This re-enrollment online process takes place of the paper application packets that Brevard Public Schools previously used and is required for all students. Guys, looking up here. Required for all students to attend Vieira High School next school year. Right, it goes on a bit, has some information. So I've still got a stack of these forms. If you need one, let me know. Those are there. Any questions so far? All right, so let's look at this. So I got this racquetball, and do you guys see that incline back there? You guys see that incline? Right. So it's over 2 meters long. What if I put this racquetball at the 2 meter mark? So guys, everybody look up here. Look up here. You gotta know what's going on. You guys, I'm gonna throw a really challenging puzzle at you guys today. Okay, it's gonna take you probably all class period to solve this. Okay. So what if I put this at the 200 centimeter mark and then just let it go? So it's released from rest, right? It's gonna roll down. It's going to leave the edge of the tabletop here. Okay. Now, okay, there's some hints I'm really dying to give you guys, but I think I'll maybe roll out some hints as we go along here. Right. And then go into a projectile motion and land on the floor, some horizontal displacement d from the edge of the table. Okay? And the question is, can you figure out what that horizontal displacement is? So way we're going to do this is I'm going to have you guys solve this on paper. Again, this is a complex problem. You need several parts of physics to solve this, including rotational dynamics. Okay? And I want you guys to show your work. So show your work on a piece of paper. If you don't have any paper, then I'll come around and give you guys some paper. Okay. And then I want every team to come up with an answer. Let me add that detail here. Okay. So each team, and there are what, 8 teams in here? 8 teams? Okay. Come up with a prediction. Okay. Then I'm gonna have you guys tell me your predictions, okay? And then the last few minutes of class, we will actually try this out. We'll do the experiment, and the winning team. Well, I've got some Reese's cups. Right, so somebody's gonna win some Reese's cups today. Want some Reese's cups? Ooh. Okay. Then whoever's closest to the actual answer. Okay. I will give you guys two numbers. Okay. So I told you the length of the incline, let's go with 200 centimeters, so drop it from that mark. Okay. The other number I'll give you is, let's call the mass of the racquetball, in case you need it, in case you need the mass, 41 grams. 41 grams, because I measured it ahead of time. I was going to have you guys do that too, but here, give you that. Okay. Now, if you like, guys, how many kilograms is that? 0. What? What? 041. There you go. 0.041 kilograms. Right? Because here's 0.5 kilograms. So what do you think is more massive? Ooh, this 0.5 is definitely like over 10 times more massive than this. This is like over 10 of these. Okay. All right. Yeah. So 0.041. You guys know 3 decimal places is kilo, right? Okay. So you know, I will give you guys another hint here too. I'm going to switch my projector screen over at some point, and so you guys, this might be applicable. Ooh, guys, what shape do you think this best fits? Yeah, think about a racquetball, right? Okay. What do you think? What do you think it best fits? Right. All right. So I'll pass this around. If you guys want to get the radius, might be important to get, right? Maybe, right? No, don't roll it down and test yourself, obviously, because we're gonna see that for the end of class. But if you want to measure this or get the radius, anything like that, or you know what? Here, maybe I'll do it for you too. Here, let's get the radius. Okay. I mean, you guys can imagine that would be a good number to get, right? Okay. What's the radius of this thing? I'm looking at a diameter of like 5.5 centimeters. Looks like 5.5 centimeter diameter, right? So could the radius be half of that? So 2.25 centimeters. Oh. 2. Wait, what did I say? 2.75. Is that right? Yeah, I think you're right. Yeah, thank you. Yeah, 2.75 centimeters. Okay. Let's call it 0.0275 meters. If that mattered, right? Okay. At least that's what I got. Oh yeah. What is the angle? Well, you know what? I'm gonna leave that rig back there, and I'm gonna let you guys make some measurements. There's multiple ways you can get this angle. Um, what ways can you guys think to get that angle? Oh, okay, so I heard someone say protractor. No, that's one way to do it. What was the other way? Ooh, yeah. Okay, so maybe if you know something about the geometry of this triangle, right? You do some play around some geometry, solve for angles, right? Like SOHCAHTOA type stuff, right? There might be an inverse trig involved, something like that. Okay, so there you go. There's two ways you guys came up with, right? You could either pull out a protractor and get that angle directly, just direct measurement, or you could measure the size of this triangle, maybe do something with trigonometry. Okay. Okay. All right. So I'll give you guys some time, walk around, check how you guys doing, and possibly throw you guys some hints here or there. Okay, go ahead, pause this recording.